My name is Achintya Datta and I will be presenting my undergraduate thesis work titled Sensitivity Tuned Polyaniline Graphite Nanoparticle Based Humidity Sensor powered by a copper graphite microsupercapacitor with PVA-PVP polymer electrolyte. This work resulted in a paper which was published in the journal Materials Letters, a paper which is currently under review in the Journal of Measurement, along with this one Indian patent which was filed in the area of flexible electronics and supercapacitors. Along with this, there are two more journal manuscripts currently under preparation as a continuation of this work. The goal of this work was to develop a completely flexible batteryless system with a flexible sensor powered by a supercapacitor. So the first part of the project dealt with the fabrication of a 2D flexible supercapacitor on a PET substrate. The method of screen printing was used, and as it can be seen from this image, the size of the device was very close to a 1 rupee coin. One of the major novelties and innovations which we brought about in this work was the deposition of the electrolyte. Conventional methods such as drop casting have several disadvantages which were overcome by our novel method of depositing using a fibrous porous structure, which essentially aided the storing of charge in the electrolyte, thus allowing the device to have high performance even in such a small size or in such a small area. The second part of the project dealt with the fabrication of a flexible humidity sensor based on a novel nanocomposite based on polyaniline and graphite, which is a conductive polymer and carbon composite. Now, as it can be seen from the graph shown here, the sensor showed exceptionally good performance as well as sensitivity in a wide relative humidity range. The method of saturated salts was used to develop different environments with different relative humidities, which was used to characterize the sensors. When integrating such a sensor with a power source, it is crucial that they have a very low resistance, which was achieved by a geometric optimization method where we varied the inter-electrode distances as well as the number of electrodes in order to achieve exceptionally low resistance. Finally, the applications of such a system are shown on this slide. The first application is a breathing pattern analyzer where the sensors can actually map the breath of a person, which can then be used to detect anomalies and diseases. This sensor can be integrated into an N95 mask as it is completely non-toxic and safe for humans. It can also be used for a traditional environment monitoring application where it can detect the relative humidity values in a room or in a small environment. Finally, the application of contactless gesture control was also developed, where as you can see here, the finger is not touching the sensor. But the sensor can still detect the motion of the finger and even map the gestures which are done because it is so sensitive that it can actually detect the humidity moisture on the finger of a person. And as you can see, all these sensors are completely batteryless as they are powered by the supercapacitor. Hence, we developed a completely batteryless supercapacitor sensor system. This was the output of my undergraduate thesis. Thank you.